sure you can read it. I couldn't if I was you. Test the given claim. Identify the null, blah, 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 blah. All right, here we go. Among 2,043 passenger cars in a particular region, 223 had only rear license plates. Among 368 commercial trucks, 51 had only rear license plates. So let me write the crucial facts there amidst the sea of words. There's 200, and what's a little big. So the important facts, 243 cars and 223 have rear license plates. And 300, what is it? 368? Yeah, 368 commercial trucks. 368 trucks, 51 have rear license plates. Okay, a reasonable hypothesis is that commercial truck owners violate laws requiring front license plates at a higher rate. What? Why are they talking about front license plates also? What am I missing? Had only rear. Oh, only rear. They're missing the front. Okay. I wasn't reading well. Only rear. Notice they don't have the front. Okay, I'm with it now. Maybe you were already with it. It says, okay, so here's the hypothesis. The hypothesis, it says, is that trucks break the law more. Trucks break the law more than the cars. Test it. Okay. All right. Yeah. Let's talk about identification, because that will be the battle come Monday night, is the identification game. So you look at this question, think about the different things we've done. Okay, it's not a goodness of fit. It's not a, what was the other thing? Categorical data. It's not like last night's homework. What is it? Two samples. Right? There's two groups. There's trucks and the cars. So it's two samples. So what do we do? What are the options within two samples? Well, notice, they're helping us. They're giving us P's right here. So proportions. You might not get exactly that on the test. I can't exactly remember what it looks like. But even if they didn't say it, it smells like proportions. It's kind of a weird way to say it. But you know what I mean? You see it? Right? 223 out of 243 have only rear license plates. That's a portion, isn't it? Right? Like if I said, 8 out of the 25 of us are going to get A's in this class. That's a portion. That's a part of a whole, isn't it? 8 out of 25 are going to get A's. 223 out of 2043 only have their rear license plate, don't have the front one. That's a portion, isn't it? That's a part of a whole. As opposed to, what is it not? It's not an average. They didn't say, the average car has 2.7 license plates, or some dumb thing like that. It's not an average, is it? It's not a mean. That's the only other option. It's either proportions or means. That's clearly proportions. Okay, so we go, all right, so I'm doing so. To test this hypothesis, I must need to do the two proportion z-test. That must be the only ball game that narrows down. Is that good? Is that making sense so far? How we recognize that? Two groups and their proportions. Okay, now we've got to write the null and the alternative. So the null, the alternative, hypothesis. All right, so we're talking about the two proportions. What do we always do for null? Yeah, so P1, whoops, I'm getting scribbly here. P1 equals P2. P1 equals P2. Okay, now for the alternative, what are they saying? Oh, yeah, who's P1 and P2 first off? I guess.
Whatever's named first.
Yeah, just put them in the order they named them, exactly. So P1 will be cars, P2 will be trucks. So they're saying trucks break the law more. Trucks break the law more. So what are they saying? Trucks break the law more.
Greater than?
They're greater. Their proportion is greater. The truck proportion is greater, so that's P2, right? So it'd be this way. Make sense? We good? The P2's on the wide side of the symbol, right? That symbol has a wider side and a narrow side. P2's on the wide side, P2's bigger. The truck proportion is bigger. That is the claim being made. The trucks break the law more often. Bigger proportion that are missing their front license plate only have their rear license plate. All right, so there we go. So we can grab whichever option that is over there. Is that C on my screen anyway? All right, let's keep going. Go to our calculator, right? So they want the test statistic, the p-value. To the calculator we go. We're going to do the 2 proportion z test and put in the information. Yeah, this is x1, n1, and x2 and n2 are below it. Is that good? N is always the denominator, isn't it? Because it's the total. Right? We're saying 223 out of 243. That's the percentage of cars. That's the proportion. That's the part of the whole for the cars that are breaking the law. Right? That's the x1 over n1. That's like the 8 out of 25 are going to get A's in here. That's the 223 out of 243 of the cars are missing their front license plate. That good? X1, N1. Now, I want to give you a heads up. On the exam, no surprises with me, some of the questions could be percentages. They will be. I think so. I mixed it up among different versions, but I believe you'll get a version that has a percentage. So, for example, what if I asked you, what if instead of putting it this way, what if they said 30% of the 500 cars only have the rear license plate, have no front license plate. 30% of the 500. So in that case, what would be, X1 and N1. What would be the X1 and the N1 if they gave it to you in a percentage? Instead of just straight out telling you, whatever here they said, 223. What would you do?
0.30 times 500 equals X1.
Exactly.
N1 is 500.
Exactly. Are we all okay with that? I don't know what that is. Is that 30 times 5? I think it's 150. So 150, and then this would just be straight 500. So that'd be okay on the exam if they give it to you that way? I couldn't find one on the homework that would do that, but you could do that. Is that good? Can you do that? Are you okay? Mm-hmm. So they give you a percentage. Of means times, doesn't it? Haley and I were talking about this on Monday. Of means times. Are we all good with that? That'll help out a lot. Whatever they say, 30% of 500 times. So that if they do that, just multiply, get your X1, your N1's the total. All right, good. Back to it. Put in everything, hit the buttons on your calculator. So make sure you choose the less than option and calculate. Here's what I'm getting. I got a Z value. Let me erase this stuff. Well, let's go to a fresh screen. I got a Z value that is negative 1.63. So I don't know how far they want me to round. Well, I'll get there in a minute. 2? Thank you. So that'll round to negative 1.64. And I get a p-value that is 0.050. They want 4 places on the p? 3? So 051. Did you guys get the same thing? Mm-hmm. The p? Good. Let's go put those in. Was test at a 0.01 level. So is our p low enough or not? No, p's bigger than 0.01. So P is not low. The null does not go. So we keep the null, right? Keep the null. What was the null? Wherever the null was. There it is. P1 equals P2. So we believe P1 equals P2, but there's weak evidence for that. So we believe that the trucks and the cars are equal. At least there's not strong evidence that they're different, that the cars or the trucks are more. There's not strong evidence. So we got all that? Questions to there? Yeah. Okay, sure. I'll run around just a second. Let's finish at the confidence interval, and then I'll move around and help you all with calculator stuff. So can we find the appropriate confidence interval? Yeah, remember that rule we learned about, like how you go from a test to a confidence interval?
greater than or less than, you times 2. So it'll be 2 times 0.01.
Right.
So it'll be 0.02, so it'll be 98%.
Right, exactly. So for greater than, less than, the confidence interval is 1 minus 2 times the percent you were using. For not equals, then the confidence interval is just 1 minus the percent.
Wait, the percent in the...
Percent they gave. In this case, the 0.01. The level they gave, the 0.01. Yeah. So we're talking about greater than, we have a greater than, less than.
For the claim?
Yeah, for the claim, exactly. Yeah, right back here, see we had a P1 less than P2. So we didn't have a not equals, we have a greater than, less than. So that means we're top case, so that's going to be 1 minus 2 times the 0.01. Yeah, that's the percentage I mean. Is the 0.01 significance level. That's the significance level of the test, of the hypothesis test. That tells me what level to do the confidence interval at. So plug that in right there. 1 minus 2 times 0.01. 1 minus 0.02. Like Val said, 0.98. 98% confidence interval. So now do the same thing on your calculator, you know. The two proportion z interval. 2 prop z interval. It's already got the x1 in 1, x2 in 2. It's nice, already got it. Just make it 0.98, calculate it. And so I'm doing the 2 prop z interval. Let me get some paper here. Okay, so 2 prop z interval. So what I got is negative point. How many places does it want? 4. Thank you. Negative 0.0743 to 0.0154. For the 2 prop z interval, the 98% confidence interval.
The interval?
2 prop z interval, yeah. Yeah, for a confidence interval, right.
So then you keep the regular numbers and then just change the confidence level to whatever.
Exactly. All you got to change is the confidence level. That's right. It'll grab, if you just did the hypothesis test, it'll grab the same numbers for x1, n1, x2, n2. It's nice. Good? You guys able to get that okay? I wrote out on the notes for you some stuff. We'll get to that in a minute. We'll answer a direct question. But basically, I put it on the notes. Yeah, is 0 in there or not? That's the crucial question. 0 is, right? Because on the number line, if you go from a negative, like 0.07 to a positive 0.01, you went over 0, of course. So 0 is in that interval. So what does that mean? Yeah, right. It could be, because remember what we're looking at here. We're looking at P1 minus P2, the difference. So if the difference might equal 0. What, do you see why I'm saying it might? So let me give you the logic even right now, because they're going to directly ask us this. No secrets with me. There's a question on the exam Monday that directly asks you to look at a confidence interval and figure out what that means, because I do think that's important in the statistical thinking. So think with me. 0's in the interval. We are 98% confident that the difference is, somewhere between negative and positive. So 0 might be in there. So that means P1 minus, and you have to remember what we're talking about is P1 minus P2. So when we say something 0, we mean P1 minus P2 might be 0, right? It's something in this interval. It might be negative, it might be positive, but it might be 0. So if it might be 0, if P1 minus P2 might be 0, what does that mean? You could add the P2 to both sides, and you'll get P1 equals P2. Or you could just think, if the difference between two things is 0, they might be equal. That means they're equal, right? If I subtract two things and the answer is 0, they're equal. Did I say that too quick? Remember I did the me and Eddie's ages. If Eddie and I subtract our ages and it's 0, that means Eddie's just as old as I am, right? That's what it means if you subtract two things and you get 0. So when we say that the difference might be 0, we're saying that they might be equal. So we're not sure they're different. They might be equal, which is exactly what we just concluded, right? That was exactly what we just concluded with the hypothesis test. We said, what? We kept the null. We kept the null. What did the null say? The null said they're equal. There's weak evidence. We're not sure, but they might be equal. See how that's exactly the same conclusion? Does that make sense? So if zero's in the interval, they might be equal. That's what that always means. Because their difference is zero, they're not different. Maybe. Zero is in there, so they may be the same. So we're not sure the trucks are more than the cars. They might be the same. Same conclusion. And that's that problem. That's a long problem. We did everything in the world. Is that good? Questions on that one? Yeah, good questions. So what if we got some kind of interval that went from like 2 to 5 or something? You know, on the number line. Here's 0 over here, and we're going from like 2 to 5. 2 to 5 does not contain 0. Well, that means the difference is not equal to 0. 0's not in there. We're confident 0's not in there, which means we're confident they're not equal. Right? Because their difference is not 0. So they are not equal. That's what that would mean. So we would have strong evidence they're different in that case. Is that good?
Is this gonna be on YouTube?
What's that?
Is this gonna be on YouTube?
Yeah, I'll put this up on YouTube. Okay, so we're on to number 3. Here's question 3. This is the one I was talking about. I'm going to directly ask you on the exam. I mean, all these are obviously exam questions, but this one's a little different. It was from our homework. It says blah blah blah, and then they give a confidence interval. So I'll just write the confidence interval. Let me just go on a fresh screen. So question 3 basically says minus 1.76 mu1 minus mu2 minus 1.62. I don't even know what we're talking about here. Large samples, women and men. Hemoglobin level. Women and men. Okay. Oops. So here's the question. Mu1 is women. Mu2 is men.
So this is going to be a meaning of confidence interval?
Yeah, exactly. This is meaning of confidence interval. That's exactly what this question is about. Meaning, and I wrote it on your notes. So the notes I sent you, I think it's question 3, right? Yeah, it says, or I don't know where it is on the. It's actually number 4. I put it down to number 4. Meaning of confidence interval. So, giving us this interval, and they're saying mu1 is women, and notice they came out negative, right? All negative. All negative. 0 not included. So if you subtract two things, let's think it out again. If you subtract two things and it comes out negative, right? We're confident that it's negative because those are all negative numbers in that zone. So if you subtract two things and it comes out negative, what does that mean about the first number? Must be smaller. Must be that, huh? Which is what? The women. So the women must have less hemoglobin than the men on average. We have confidence of that based on these sample data. That's what that means. Let's see how they ask it. They say because the confidence interval, we're going to say does not include. Does not include.
So this one is no functional calculator?
Right, no, it's just all thinking it out logically. Yeah, nothing to do with the calculator, right? Does not include 0. It appears that they're. So what do you think? If 0 is not included,
There's a significance.
are we confident that they're different? Yeah, absolutely. Right? Because this is our confidence interval, and we're confident there's no 0 in there. We're confident they're not the same. They're not equal. Their difference is not 0. So we are confident. So yeah, so there is significant difference between them. All right, write a brief statement that determines it. There is 95% confidence there's a difference. No, that's not right. There is 95% confidence. No.
Did the last one? D?
Is it B?
I think it's B. Let me finish reading them. Yeah, it's B, right. See, B says there is 95% confidence that the interval from negative 1.76 to negative 1.62, the two numbers, actually contains the value of the difference between the two population means. Does that make sense? Remember, we're always looking at samples, trying to figure out something about the truth. So for this little group of men and women we measured, it came out such strong results that we are, whatever it said, 95% confident that it's true of all men and women. That's what we're saying. That the true difference with all men and women is somewhere in that interval. We're 95% confident that we've got to the real truth of the real difference between all men and women based on our sample groups. That's what we're saying. Good on that? Questions? Question. They ask kind of a goofy question. I'm not going to ask you this on the test. They say express confidence interval with measures from men first, then women. So basically, if you flip it around, it's just going to change the signs. Instead of women minus men, then they went, hey, what happens if you go men minus women? Well, if you subtract two things, like originally we were going like 2 minus 7 and getting a negative answer. If you flip it around, you're just going to get the same thing positive, huh? If you switch the order of subtraction, that's all they're talking about. There was women minus men. Now they want to go, okay, how about men minus women? Well, if you switch the order in which you subtract, that just changes the sign of the answer. So it's just going to be, so what were the numbers before? It was minus 1.76 and minus 1.62. Now it's going to become plus on both. Both numbers are plus. There it is. That's all. It's kind of a dumb question. All right. Right. Okay, so we have some data here. Yeah, a couple of means. Proctored studies done on proctored, non-proctored tests. Results are shown on the table. So the two samples are independent. Blah, 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 blah. Okay, so test the claim that the students taking the non-proctored test get a higher mean score than those taking the proctored test. So those that have no one proctoring get a higher score. That's the claim. Claim the non-proctored is higher than the proctored. So yeah, on this one, it's two groups again. It's just means instead of proportions. I think you'd recognize it. Does it seem recognizable? So we'll just see it on the exam Monday. Because there's mu's here instead of p's, and they're literally saying, they're literally saying the word mean, higher mean, instead of proportion. Is that good? We just shifted from proportion to mean. So this is going to be a 2 sample, what is it? T-test. Yeah, 2. I put it in the notes for you. It's a 2 sample t-test. Now, part of the trick is there's independent and dependent, but I think you'll be able to recognize it. I'll show you especially when we get to the dependent. It's the ones where they list them all out in matched pairs. We'll get there. But this one right now, it even says the word independent. Notice right there. It says these two groups are independent, meaning they're not matched up in any particular way. It's not like husbands and wives or the other ways we match things up. It's not like that. It's just two random groups. So 2 sample t-test is what we're going to use. And so should we do this one? Put the information in. Let's crank the information into your calculator. Oh, first off, what's the null? Yeah, what are they? Yeah, it's always equal here. Yeah, what's the alternative?
Greater.
Is that what they're saying? Oh yeah, higher. Yeah, greater. You're right. mu1 greater than mu2 because they say higher there. It's greater, huh? Yeah, students. Yeah, non-proctored. mu1's non. Oh wait. Oh no. Oh, look, they're trying to trick us. Look at that. They reverse the words, the order. Check this out. See, this is number 1, number 2 in the table. They put proctored first, non-proctored in the table anyway. And then when they read the question, they put non-proctored. And proctored afterwards. They swapped them. You see that? So let's be careful. They're saying, okay, non-proctored, that's mu2. mu1 is, say right, mu1. See it right there in the table? So what they're saying then, let me be real careful. Watch these words. So they're saying non-proctored, which is mu2, right? Non-proctored mu2, higher, greater than proctored mu1. That's what they're saying. Yeah, so it has to go the other way. Right, you okay with the fact that this and this are saying the same truth now?
Right.
Now they are. Right, because in both cases, mu2 is on the wide side. He's the bigger one. So mu2 is bigger, down here, same thing. So it doesn't really matter which way the symbol is pointing, as much as it matters who he's open towards. Whoever he's open towards is the bigger. Right, so the symbol is open mouth to mu2, saying mu2 is the bigger one. Open mouth mu2, same truth. In both cases, mu2 bigger, mu2 bigger. So the right and left doesn't matter, just which side of the open mouth, are you on the open mouth, you're bigger. Okay, so you've got to be a little careful. They're trying to trick us. There. All right, so that's that. Let's do the test statistic. Let's crank these numbers into the calculator. Can you read it? You want me to make them bigger? When it has lists. Exactly. Any, and lots of them will. When they have the lists, that's data, and you got to put stuff in L1 and L2 first, then you choose data. Data means it's going to grab what's in L1 and L2. Exactly. This is summary statistics. We choose stats. Put those stats in. We're choosing, what are we choosing? It was less, wasn't it? Less. So choose the less option. Yeah, choose the less, and the pooled is no. It's always no. And calculate. So I got an answer now. I got T is minus 2.355. They want two places? Or three? Two. So 3.6. 2.36. And the p-value, 3.011. Did y'all get that?
Wait, what?
Those that are doing the mining. So I chose the less because our alternative hypothesis was mu1 less than mu2. What was it? 0.05, yeah. 0.05, yeah. 0.05 on this one. So is that a low P or not? Yeah, that's less than 0.05. So the P is low. The HO must go. The HO must go. So here, I'll put it up here again. The HO was, not P's, was mu1 equal mu2. The alternative was mu1 less than mu2. So the null must go. Cross off the null. We believe the alternative with strong evidence that mu1 is indeed less than mu2. The proctored scores are lower than the non-proctored. Is that good? And is there anything else? Good for the hypothesis test. Let's do the confidence interval. Yeah, and we got to decide which level. There we say the appropriate confidence interval. So let me let you figure that out. Remember, if it's not equals, it's just 1 minus it. And if it's greater than or less than, if the the H1, which ours is, less than, then you do 1 minus double it. And theirs was the 0.05. Their significance level for the hypothesis test was the normal 0.05. So we're going to do 1 minus double that, aren't we? For a confidence interval. So, write that up here. So the confidence interval will be 1 minus double the 0.05, 1 minus 0.10, 0.90. So we're going to do a 90% confidence interval on this one. So remember how that works? So put that on your 3x5 card. If it's not equals, then we just take 1 minus it. We don't double it. So 90% confidence interval. Everything else should be the same. So it's going to be 2 sample T interval. Two sample T interval or int or whatever it says. We have 2 sample T interval. Int, INT. And it already has the data in there, x1, everything. You just have to check the, just set the confidence level. Pooled is no, always. Calculate. I got, what did I get? Negative 15.88, comma, negative 2.683. Did y'all get that? For my two-sample t-interval. And then they're going to ask you, what does that mean? Is 0 in there or not? No, 0's not in there. So there's no way their difference could be 0, or at least we're confident that their difference is not 0. So they're not the same. Right? So same conclusion. Confidence interval always backs up hypothesis. Data tell the same story, whichever way you look at it. Is that okay? Say, yes, it supports. So it supports because it's only negative. Only negative. Which means the difference is negative. Meaning mu1 minus mu2 is less than 0. Negative. You subtract two things and it's negative. What does that mean? What does that mean about the, if you subtract two numbers and it comes out negative, what does that mean about the first number? Smaller, which is exactly what we concluded, right? It totally supports the claim.
So if it contains 0, it's no.
Yeah, if it contains 0, it's not significant evidence. It could be no difference. It could be 0. Yeah, that would be how we do that. Okay.
So is this one that two dependent matched pair sample means?
That's the crucial question. Eddie's question is the question of the hour. That's the, if there's anything that's going to confuse you, it might be that. So let's make sure that doesn't happen. How do you tell the difference between like the matched pairs and the ones that are two independent samples? Well, on this one, they just tell you somewhere.
It doesn't independent.
Yeah, where does it say it?
It's on the second line.
Second line. There it is. Yeah, I knew I'd seen it. Yeah, right there. So yeah, because it sure they have to tell you, because otherwise we wouldn't know on this one.
So this
Yeah.
would be two dependent then?
So this one says independent. So they're saying they're two independent samples. Notice there's no connection between them. So as you look at this data, it kind of looks like they are, especially because they're the same number of values. That's what matched pairs usually look like, huh? They're saying it's not matched pairs. It's just, I don't even know, what is this data about? Oh, strontium 90, whatever. There's some kind of stuff. So they're just saying, hey, city 1, these are just a bunch of people that happen to be in city 1. We just grabbed them at random. That's how much strontium 90 was in their system. These are a bunch of people out of city 2. So those are independent. What would dependent be then? Well, that would be like if they had husbands and wives, or brothers and sisters, or, you know, or, I don't know what else to do. But some other kind of matching where there would be a definite connection. Like if this was brother and sister, brother, sister, brother, sister, brother, sister, and how much strontium they had, that would be dependent. Because there's a connection there, right? What brother and sister, biological similarities, on. There's a dependence, a connection. Or husband and wife, they're living in the same area, you know, connection. But this, two independent, no connection. Just one city, bunch of people, another city, bunch of people. See that difference? So matched pairs are when they're matched up with some characteristic. They're married, or they're siblings, or something. This is independent, no connection.
So we're using two-sample t-test again, basically?
So we do two-sample t-test again. Exactly. Just going to be two-sample t-test. Because they say independent, it's just two-sample t-test. I just wanted to give you one of those. You would use the data button on this one, right? Instead of the stat button.
So,
Put in and you put the data in L1 and L2. Put this list. This will be L1, L2. Put it in there. Choose data. Question, Eddie?
yeah, I was gonna say, so if it says, like, you know how you said it said independent in the paragraph?
Right.
If it said dependent, would that?
We'll get to that. That'll be our next example. I'll show you.
It does
Okay.
says random. So that means there's no connection right there.
Yeah,
Random.
right. Good eye. Yep, random, no connection, totally. It's two random groups. Yep. Yeah, we'll do one of those other ones in just a minute. We'll do it all the way. We'll do that one all the way out. But so this is enough for this one. How about the rest is the same as the last one we just did?
For the first part, it would be equals and equals.
Yeah.
Equals the
So the null is always equals. And then the H1, I don't know, whatever they're claiming. What's their claim?
Greater than.
It says,
Yeah, greater than the mean amount.
okay, I can't find it. I trust y'all. And mu1 greater than mu2.
It's in the last line.
Oh, yeah, there it is. Greater, yeah, thanks. Yeah, so just like that, the rest is the same as the last problem. Just do the two-sample t-test, all the rest of the stuff. Okay, let's get on. Okay, so here we are now on question number 6. And these are matched pairs. Let's do this one all the way out. See the difference here. Just see, would you recognize on the exam Monday that these are matched pairs? Because they're all matched up, right? This is the actress's age who won the award, and then the actor that same year who won the award, how old he was. And then, these are same year. That's the match. So these two, that was the best actor, best actress that year. These two next year. So that's a matching up, isn't it? There's some kind of connection there. If the culture was really into old people, young people, whatever, that year, then so be it. And then those are matched. And, so there's a reason where the data kind of tends to go together.
It does say match right there, too.
And does it? That's nice, too. It just says the word match, yeah. So, in this case, then, we're going to do something special. So it's in your notes. I'll write it on the board as well. So, in fact, let me just write it right here. Probably be better to be on the YouTube. So the matched pair, I put that as number 3. 2 dependent matched pair samples. Okay, what do you do in that case? Well, you start off, no big surprise, data into L1 and L2. No big surprise there. But once you get, here's the difference. Once you get it into L1 and L2, we're not going to choose to sample anything. We're going to do the L1 minus L2 stored into L3. Remember that? Been a while. Store button's in the lower left corner. So after you got the whole L1 and L2 lists in there, grab the store button, lower left corner, right above the on button, and you literally type this on your screen. To get the L1, you got to go set. To get L1, you hit second and the number 1, and second and the number 2, and then the store button, and then the second and the 3.
That's for the answers for the L1 and 2.
Yeah, it basically takes the L1 column minus the L2 column and pops it into the L3 column for you. It subtracts them all for you and stores it in L3. The differences. It does all the differences and puts them in L3. And then we'll just, when we do the test, it'll all be on L3. Because all we care about is the subtractions, the differences, which will be in L3. So here, let me go back and I'll go back and forth between these two. Let's get the data. So this will be L1. This list will be L2. Ooh. We good? We got that?
Wait, so mu is always 0?
Right. That's. Whoop, I wrote the same thing twice, didn't I? So. All right. So put that data in there. Store that, and then we're going to do, like I said. Then you go up here. You go second, quit. When you're done putting data into L1 and L2, quit, hit enter at the end of this. The way you get L3, yeah, you know. Oh, I already wrote it. What am I doing? All right. And then you got to go to the t-test, choose data, and mu0 is 0. Remember what mu0 is? Whenever they put a sub-0, that's just whatever number's by your null, right? That's the sub-0. Yeah, in our case, always going to be 0. Always going to be, because you're saying the difference is 0. That's what you're saying. And the list is L3. Did everybody get L3 in the list? That's crucial. They want L3. It's all based on L3 now. So this is how we handle matched pairs. We don't do any of the 2 sample buttons. We just store into L3, and then just do a normal t-test on L3, the differences.
The number 2 option, t-test?
Just normal t-test. Yeah, just normal t-test, but choose data. Normal t-test, choose data. Put it in L3, hit the buttons, and I'll do it too. T-test, data, 0, L3. Oh, is it greater than or less than? What did it say? What was, I didn't even know what they're claiming. What are they saying? What are they claiming? Did y'all find the claim anywhere?
I'll mean less than 0.
Less than 0.
Well, how are you getting that? Where does it say that?
A, on A.
Use sample data, test the claim, after the population. Age is a best actress. The difference have a mean, less than 0. Right, okay, so the HO is always equal to 0. The H1 is less than 0. Good. Okay, so less than 0, yeah. So there we go. So that means we're going to choose, so on this screen, HO is equal to 0. H1 less than 0. Okay, yeah, so we choose the less than option on our test and calculate. All right, so I finally got some numbers here. What did I get? I got a T. Maybe I'll put it over here. I got a T that is negative 2.87. Anybody getting that?
Yeah.
And P is 0.009. I just want 3 places. 009. Not coming out. So what does that mean? Is that P low? What was the test low? 0.05? I don't even see it.
Right there, 0.01. On A, you have a red line over it, that's why.
Oh, yeah, thanks, Mike. Yeah, there it is. 0.01, thanks. Anyway, that's lower than 0.01 even, huh? So that works. Lower than 0.01, right? 009. It's lower than 0.01, so the P is very low. The null must go. Press out the null, accept the H1, evidence is strong. H1, we believe the mu is less than 0. Difference is less than 0. So, is that good? Is that making sense? How to see the matched pairs and put that on your 3x5 card. What you do for matched pairs. Questions I can answer?
For match pair to do the confidence interval?
Oh, they want that? Yeah. What level confidence interval do we do?
So what is it? It's going to be double.
It's, because it's a greater or less, so it's double again.
What's the confidence interval?
And this was a 0.01. This one was a 0.01. Yeah, so the confidence interval is going to be 1 minus double 0.01. 1 minus 0.02. 98% confidence interval. Now, when you do the confidence interval, you're just like for the test, we just did a normal t-test. We're just going to do a normal t interval. No 2 sample anything. Just the normal t interval.
Has to match what you did in the first one.
Exactly.
So
Exactly.
that's why we decide what confidence interval to do.
That's right. Rather than the 2 sample one.
First.
Yeah, whatever we did in the first.
Wait, what?
Yeah. So we're about to do the confidence interval.
What is the test?
We're just going to, remember for the hypothesis test, we just did, where is it? Normal t-test, didn't we? In other words, we didn't do 2 samples. Everybody's seen this. This is the main point. So everybody catch me on this. When you do the matched pairs, you end up sticking everything in L3, and so all of your tests are just on one data set in the end, L3. So you don't do any 2 sample anything any longer for the matched pairs, because it's all in L3. So you just do t-test normal, t-interval normal. as if it was never two groups.
And if it was a sample, you'd be sample T interval or sample.
Well, for the last ones we did with the independent groups, we did two samples.
So there would be two sample interval or.
Yeah, and that one had a two sample interval, which we did.
Okay.
That's right. So we're not getting that now.
Right.
Does that make sense? So just remember when you put everything into L3, now you just have one list. And so you're not doing two. Not doing two for anything. Not for T test is normal, T interval, just normal, T interval. On L3 though, you got to do it on L3, so make sure your list is L3 when you do your T interval. So do the T interval.
For L3 confidence interval, you just do the T test interval?
The T interval, it's called.
T interval.
I just keep.
Yeah, just T interval. It's not like number 8 or something. Choose data. Choose data and L3. And the confidence level is 0.98.
That's when I do the T.
And I'm getting negative 23.42, negative 0.1837. What does this all mean? So, it's all negative. No zero included. So no zero included. So we believe there's a difference, huh? Yeah, right. So there's, the difference is negative. So that's strong evidence. Strong evidence, reject the null. Reject the null, reject the zero, right? Because the null was zero. And there's no zero in there. Same thing we got.
If my confidence interval includes zero, it means, reject the null?
No, keep the null. Because the null has the zero. So if you have a zero in your interval, keep it. Is that good? Mine did not. Mine did not have a zero in it.
So it's at the end where it says zero is included. In case zero, you fail to reject.
Right. Yeah. So let me say it in a way that makes sense for you. Right? So do you see what's happening? So basically, the null was equal to zero, right? So, so just in general, if you got zero in your interval, you're going to want to believe the null. He was all about zero. And if you don't have zero, then you're rejecting the null, which is what my data did. Good? All right, so that's matched pairs and two independent samples. All right, this is number 7. Yeah. First off, they're just all matched up, same number of data. If they have different amounts of data, then that's for sure independent. These are matched up. Basically, it's all context, because if you read the story, what they're talking about is a president, somebody who became president, and his main opponent. President, main opponent, president, main opponent. So that's a connection. That's a matching up. It's not just like 10 random presidents and 10 random senators or something. No, it's person with their direct competitor. So that's a matching. That makes sense? So it's always actor, actress, husband, wife, president, and their main opponent. When they're matching them up like that, that's when you're going to do the whole L3 thing and just like that. Yeah.
So is it safe to say that whenever you see like the little mu sign with the D, it's always going to be a matched pair?
Yeah, I don't think it. You're right, but I'm not going to put that on the test. It's all right. Yeah.
What are you not putting on there?
I won't put that mu D. I'll just put you the words. But yeah, you'll recognize the match, right? When they're matched up by some kind of characteristic. Main opponent, husband, wife, actor, actress of the same year. Something connects them. They're matched. All right. Question 8. 5, 6, 7, 8, right. So in question 8, we're talking about R values. So R, correlation, linear correlation coefficient. Okay, so they're giving us those numbers, and they want us to match up with the pictures. Remember how this generally looks? I put in your notes, if R is basically 0, there's no linear correlation. If R is basically +1, then there's a strong positive linear correlation. If R is basically -1, there's a strong negative linear correlation. I mean, a line going down, line going up for the positive is up and negative is down. Remember that? The closer it is to +1, the stronger it's a positive line. Closer it is -1, stronger the dots are tight in a down line. Line going down, slope negative. And if R is about 0, there's no linear correlation. This is all to determine if two variables have a linear relationship. They could have a curved relationship. It won't detect that. It's just for whether they line up or not. So let's look at the pictures. So there's a bunch of pictures. They want you to match these different R values with the pictures. How about we start with the biggest positive one? This one that one's basically positive 1.0, right?
Yeah.
That's basically +1. So which one of those graphs is basically +1? A positive up line. Yeah, this one, +1, basically right there. And then how about this one? This is basically -1. That one, right? Okay. Now the rest will be a little. Two of those are the same to me. Anyway, which one is the strongest next result?
Maybe 75.
Yeah, I think this one's somewhat close to -1, not as close as the others. So let's go back, find a line going down.
1.
Yeah, I think so. Looks like it's kind of a line going down, The best fit line, the regression line, which we're going to do those in just a second, would fit kind of like that probably, that best fit line.
Yeah.
About like that. Now the other two, maybe this one's a little bit positive.
What ends in the positive?
Yeah, I think. Whoop. Let's see, which one's positive? I guess that's the positive, 0.39, and the other's the negative, I guess, kind of going down. Is that good? Feel like you could do that on the test? Just a general sense. I will give you something like that, general sense of what.
Is that how you're gonna set it up? Like, we just.
I'll probably just give you a picture and say which R value is it, or I don't know, I haven't actually made it. Something like that. Something with dots and an R value. So now they're giving us a big data set. They're basically saying, here's a bunch of data, different countries. Remember we did this one before. How many internet users they have in their countries and how many award winners for some kind of Nobel something or other award. So basically it's saying, hey, in countries that have more people using the internet, percentage, I guess what's percentage of the population is using the internet, do they have more Nobel winners? Is there a linear relationship between internet users and award winners? If your country has a higher percentage internet, you win more awards. Let's figure it out. So it's pretty easy, right? Just put that in L1, L2, and then we're going to do the linear regression test on the thing. So I don't think there's anything super tricky. Let's just do this one real quick. So L1, L2. There's no snags I can think of. So then choose, what's it called, linear regression. You could roll over the top. It's down to the bottom of the list if you want to roll over the top. It's quicker.
Stats and then test.
Yeah, stats, test, and then go upwards and you'll roll to the bottom of the list. You'll find it quicker. It's lin regression t-test. Linear regression t-test, yeah. So put in L1 and L2. Choose linear regression t-test. And then, yeah, what Val was saying is true. The null for linear regression is always that R is 0, and H1 is always it's not 0. So that, R equals 0 would mean no linear relationship, right? So the null is always no linear relationship. That'll be in the notes. I think it already is in the notes. Yeah, it is. I remember typing it in because I had to search for the not equals thing. So and the H1 is R not equal to 0. So that's always, so you put that right into your 3x5 card. For linear regression test, always, R is 0, R is not 0. No other numbers ever. Never a greater than or a less than. Never going to do it. Always not equal.
So after L1, L2, you go to
Yeah.
the regression test.
And you choose not equals. Yeah, so put in L1, L2. Yeah, go to linear regression test. You're right.
Not equal.
Choose the not equals and calculate. So I got, it's going to ask me for the R. I got an R value 3 decimal places, so, wait, where is the R value? 0.588, at least from my data. Anybody get that?
Now they,
Wait,
what's that, I'll write the R for that, they don't want that one? Cause there's an R squared in the R.
Yeah, they want the regular R. Oh, you're right, I grabbed the wrong one, didn't I?
Yeah.
Yeah, no, I'm looking too quickly. 0.767? 0.767. Yeah, they want the regular R, 0.767. The R squared has meaning, we're not going there. So 0.767.
okay.
Got that? So that's, oh, and then how do you get the scatter plot? Remember how they're going to ask you to graph which one's the right scatter plot? You can, if you already got it set up, you can just hit zoom 9. If you've already turned stat plot 1 on and selected the right graph, which I think we're all there from the homework probably still, just hit zoom 9. Zoom's at the very top middle.
Second stat plot?
I think you can just hit zoom 9.
Zoom 9.
Zoom 9. Boom.
Oh.
Unless you've changed something in your setup, I'd be glad to help you. If zoom 9's not working, let me know. When you do the zoom 9, zoom's at the top middle, you get something like that. You getting that? At least for that data, you should get that.
Yeah.
So, yeah. So that's all you need to hit. So we got the R value. They're going to ask us some other questions. They're going to say, is there strong evidence? Well, that, as you know, is all about the p-value. So go down and get your p. We're getting the p-value, I don't know, what is it? 0.075. And I don't know if they want a t. They probably want a t value as well. 2.39?
Yeah.
2.39. Okay, you guys able to get those okay? Yeah, they want all that stuff. They want the t, they want the p value, they want the r value. And then they want a conclusion. Same thing as always. So is that p high or low? Yeah, it's high. It's greater than 0.05. I assume they said 0.05 level. I think they did.
0.01.
Oh, 0.0, so it's certainly greater than that. So that's not low. So the P is not low. The HO does not go away. So we keep the HO. Yeah, we fail to reject. We have weak evidence that there's really no linear relationship here. R is 0. We don't think there's not strong evidence of a linear relationship. Right? When R is 0, that means no linear relationship. At least there's not strong evidence. Is that okay? That was pretty straight ahead. I don't think there's anything real weird there. Let's get on before we run out of time to where we have to plug in the X and stuff. And sometimes you don't. Remember that? So, okay, we're still doing that linear regression kind of stuff. But these are the ones where they're going to want us to come up with the equation and then either plug in or not. So they're giving us best actor, best actress again. And they're saying, hey, find the regression line equation. It's the same thing. It's that same linear regression test. It's all the same. But let's go ahead and do it because we need to look at the p-value, remember? And if the p-value is low, then we go ahead and use the equation because it's telling us it's good. And if it's not, we don't use the equation. You have to distinguish which one to do. So let's do that. It's been a while since we've done that.
Well, P lower than.
So I just ran the numbers.
Okay.
I got a p-value. Yeah, you guys are right. P is 0.25, isn't it? It's a high p. So anyway, yeah, so first off, we have to put in this and this, the regression line. That's A and B, right? So A goes here, B goes here. It's telling me A is 52 something. Point. How many places? One decimal place. 52.7? Yeah, and B is negative. Is it rounds to 0.2, I guess? Y'all getting that for the regression equation, A and B?
Wait, what?
So when you do it's the linear regression t-test like last time. Same as the last one. Yeah, that's all we do for these, linear regression kind.
It's high.
So hit that one. Here's the p-value. And then the a and the b are the a and the b in the regression equation. In other words, that's the line that goes through the middle of the dots. That's the equation of line. Remember lines from algebra? That's like slope and intercept, or that kind of thing. It's the equation of the straight line that's in the middle of the dots. That's what it's calculating for you, the equation of that line, that best fit line. It's called the best fit line. It fits through the middle of the dots.
Okay, so,
But, well, first of all, is everybody there?
well, when so P is high, you use the formula.
Yeah, so let's get to some conclusions about it. But is everybody getting the A and the B okay? That coming out? So yeah, now the question is that line really good? Are those dots reliable? In other words, let me show you what I mean. You could have some data that ends up being dots like this. That's a pretty tight fit. You know, those look like they're in a line, don't they? And when you calculate the best fit line, that line should be used. Because that data looks like it really is lining up, right? So when you get the equation of that line, that a plus bx, you know, that the calculator gives you, use it when p is low. So when p is low, remember that always means strong evidence, doesn't it? It always has. P low means strong evidence. And strong evidence what? That the dots really do form a line. Strong evidence of a linear correlation. That these things have a linear relationship. So in that case, you will plug in x. So that's case 1. Down here, case 2, what if you have a bunch of dots that are just kind of crazy random, like that? I mean, that's not a line, you know? Those dots are not in a line. Now, the calculator will still calculate the best line it can. It'll always calculate the best line it can. But you should not trust that line. You should not use that line because the data, there's not strong evidence that that data really is linear. So in this case, line should not be used. The P is not low. It's not linear. There's not a linear correlation there. So don't use the line. Well, what are you going to do then? Because they're going to ask you for the predicted value still. Remember what we did in that case. We're not going to use the line at all. The line should not be used. Instead, just find the average of the y values. In other words, if they want to know what to expect for y, just give them the average is all we're doing. Because we're saying we can't use the line. So how do you do that? You go to stat, calc, calc, and then you got to put in L2, right? Is that what it is? Calc, the one variable. The one variable, and then you got to do L2 because they're asking for the second variable. There always will be. They're asking for the y. So when you get that, use the x bar. That is the average. It's actually the average y, even though it says x, it's the average y value because you're doing it for L2. And L2 is all y values. Does that make sense? Do you see that difference between case 1 and case 2?
For case 1, what is x though? What is plug in x?
Oh, plug in x. They'll give you an x. Like, let me show you.
I think that one's 38.
Here. There it is. There's the x value. So they're saying, all right, use this x. And we do that.
And if not, we do the other way around.
So when P is low, use the formula.
15.
The answer though?
What's that?
When P is low, use the formula.
Exactly. We go back to right. When P is low, plug in the x to the formula. Use the line because it's a linear relationship. The line's is good.
I'll give you this, the values.
Yeah, mine was 0.50.
So, can we answer it?
So yeah, let me show you what I got. I got.
I'm kind of confused on that one.
I'm getting 45.
Yeah, 45.
45. So I got 45 when I did it. I got x bar 45 because I did not use the line because the P was high. It was not low. So 45. So in other words, what they're saying is they're saying, okay, look, is there a linear connection here? Turns out no. And then they're saying, hey, we've got an equation anyway. So what about if the best actor is 38 years old? How old do you think the best actress is going to be? Well, we're not going to use the line. There's no relationship. There's not strong evidence for relationship. So instead, they're basic. It's like me just asking you, hey, here's how old the people have been historically. How old do you think the best actor? Oh wait, no, we plugged in the wrong number, didn't we?
Yeah, I think so.
Well, I mean, we didn't plug in any number, so it doesn't matter. 38 was the other conclusion. Anyway, they're basically asking us, how old do you think the best actor is going to be? Well, you would just take all the actors' ages, just to add them up and find the average. Does that make sense? That's how. If somebody asked me to predict next year how old the best actor is going to be, I would just add up all these numbers and find the average. That's my best prediction.
For the actor.
For the actor. Yeah, they're asking for the actor. Yeah, I didn't make that question very clear. Saying, okay, if the actress is 29 years old next year, who wins, how old do you think the actor's going to be? Well, it turns out we don't plug in that 29 because the P was high. So what do we do instead? We just take these actor ages and we just found the average. That's our best prediction for how old he'll be. Just take the average of what's happened in the past. That's all we're doing. And how we do that is we do stat, cal. Yeah, I wrote it here, I think. Oh, here. Yeah, right here.
But that one is what, 45?
Yeah, it came out 45.
Is it round?
Stat, cal, one variable, L2, is the average. All right.
That count.
And if that